Hey guys, I'm going to do a couple of examples for you on how to find the original amount after a percent of increase or decrease. I'm going to do it as a proportion and I'm going to do it as an equation. I prefer to do it the equation way. Maybe you'll see why when I get through the examples. But software company in Blueprint currently bills clients $366 per hour for work done by its consultants. That's the current bill, that's the new. That is 22% more than the company used to charge before adjusting its rates. So 22% more, that's an increase, right? And this is the new value. They want to know what the previous one, they want to know what the previous hourly billing rate was. So you don't know the original, what you know is the new, and what you know is the percent that it was increased. So if I use the proportion, let's use the proportion first. If I use a proportion, well, remember you always have 100 down here, right? And the percent that changed was 22%. Okay? What goes up here, what goes down here in this denominator is the original amount. The original amount's unknown because we know the new amount. So the original amount is unknown. I'm just going to call that X. And then the numerator is the amount of the change. Remember the amount of the change. Well, I don't know how much it changed. I just know what it is now. It's 366 now. So if it's more now than it was before, the amount of the change is going to be the new price minus the old price. So it's going to be the new amount, 366, minus the old amount, the original, which is unknown. And there's my proportion. And I'm going to cross multiply. Just go through this again. This is the amount of the change is the new amount minus the old amount because it was an increase. You're doing the larger amount minus the smaller amount. The increase means the new amount is larger. 366 minus the original unknown. The denominator is the original, that's unknown. The percent that was changed was 22, always over 100. Cross multiply, and you get 22x is equal to 36,600 minus 100x. Now solve this equation. I have variables on both sides. I'm going to add 100x to both sides. Plus 100x plus 100x. So now this says that 122x is equal to that large number, 36,600. And I'm going to divide by 122 on both sides. Writing out the steps for you. You don't need to write out these steps every time if you're comfortable with them. And x is equal to 36,600. Use a calculator, please. 36,600 divided by 122. And x is equal to 300. So x is equal to 300. X is the original amount, the original price. And the question is, what is the previous original hourly billing rate? So we think the answer is 300. That seems legitimate. I'm going to type that into the box, but I'm not going to enter it yet because I'm going to do the same problem as an equation. The equation using the idea of the 100% original start. So if you started as 100%, wherever the original amount was, wherever the original hourly billing rate was, and you went 22% more, you are now 122%. 100%, 22% increase, 22% more. 122% of the original amount, which we don't know, X, is going to equal the new amount. And the new amount is $366. Well, now I'm just going to change this percent to a decimal, change my of the multiplication. So now it's 1.22x is equal to 366, and divide both sides by 1.22. And you might be able to figure out the answer. You might be able to predict the answer based on what we have on the side over there. 1.22, but if you can't, I will divide it for you real fast. 366 divided by 1.22, guess what you get? 300. So two different ways to solve the same problem. Proportion, using the difference as a subtraction, or equation, using the idea that you start with 100% and you change by increasing in this case. 300, let's see what they say. Fantastic. All right. Let's delete all that real fast. No, this is another more. I want to do a less. So let me just skip real fast. Not larger again. I really want to get a less. There we go. After changing the amount of time he works, Tom has begun earning a salary of $211,968. Tom makes a lot of money. Good job, Tom. That's 10% less than before. Uh-oh, Tom's making less now than before. How much did Tom's salary used to be? Well, I'll do the proportion first. I'll do the proportion with that same setup as before. Always 100 down here. My percentage of change is 10% because it's 10% less, decrease, right? So his new salary is $211,968. That's the new amount. We don't know the original amount. So the original amount is unknown down here in the denominator. And the numerator is the amount that it changed. Well, this time the original amount is more and the new amount is less. I always want to do the larger number minus the smaller number. So the original amount, which was more, and subtract that 211,968, the new amount, and that'll tell you how much Tom's salary changed. The amount of the change. And now cross multiply. So x times 10 is 10x. And it's equal to 100 times that, and you distribute, so I get 100x minus 211,968, and slap on a couple of zeros for the 2 zeros in the 100. Big numbers. And now I need to solve for x. I have x's on both sides of the equation. So even though it kind of breaks my rule of subtracting or getting rid of the smaller amount, I'm going to subtract 100x because the left side only had the x. It didn't have a constant. So I don't want to move everything to the right. So this is going to say negative 90x is equal to negative 211,968,0,0. And I'm out of space here to write it, but you're going to divide both sides by negative 90. So let's see. 211,968,0,0 divided by 90 is a final answer of, let's see if I can put this over here. I'm going to put it over here. 235,520. It's the answer I got from that. $235,520. I'm not going to enter it yet. Just want to make sure it makes sense. First of all, let me think. Tom made more before, and now he's making less. He made more, 235,000. Now he's making less, 211,000. Always make sure the change goes in the right direction. Use a little bit of number sense there and just make, hey, does that go in the right direction? Did I do it the wrong way? I'm going to do the equation too. You'll see maybe the equation is shorter. If Tom makes 100% originally, always made 100% of his salary. Now he's making 10% less of his salary. So now he's not making the full 100%. He's only making 90%. He's only making 90% of his original salary, which is unknown. But I do know that 90% of his original salary, after he takes that 10% less, is going to equal that 211,968. Convert this to a decimal, change my of the multiplication. 0.90 or just 0.9 x is equal to 211 968 and divide both sides by 0.9 or 0.90. And again, you might be able to predict, but I'll do it just to be safe. 211, 968 divided by 0.9 is equal to, there it is, 235,520. The same answer with less work. Proportion works. I just find it more complicated. If you can get the concept instead, conceptually, you can say, well, he always started with 100%. The original amount is always 100%. I'm either adding to make more than 100% or subtracting to make less than 100%. And that's the new percentage. So the new percentage of the original will equal the new amount. Make sure I'm right here. Let's see. Let me clear this out. Make sure I'm right. Tom used to make $235,520. Tom made a lot of money. Good job, Tom. That's the two ways you can do it. Again, either way works. If you prefer that proportion, write it out. It's just a lot of things can go wrong in that proportion. If you conceptually instead think, I know I started with 100% and I'm either increasing to be more than 100% or decreasing less than 100%, that's an easier way to do it. I'm gonna skip ahead one time, see if I can get one of these questions. Let's see real fast. No, not gonna do it for me, but there you go. Good luck. See how you do.